Welcome, everyone. Again, this is Nick Milo. It's 10:04 here in the U.S., and we're going to get started. And I want to welcome everybody taking time out of busy schedules, especially close to the holidays, for joining this morning. We greatly appreciate it. We're going to keep this to an hour, and I promise it will not go longer than an hour unless you participants have some questions for us, so we'll be mindful of schedules. But welcome, and we're going to be talking this morning, as the opening slide says, our open network platforms. And again, my name is Nick Milo. I am the Vice President of Sales for Agima Systems. And joining me today as our subject matter experts who will be our speakers and carrying the discussion through is Daman Chowdhury, who is Director of Systems Engineering for Agima Systems here in Fremont, California. Also Saji Nathan, who is the Director of Product Marketing or Product Management, if you will, for IP Infusion, also headquartered here in the Silicon Valley. So just a little bit, I just want to kind of go over who we are. Agima Systems, as this slide says, we're the leading provider of open platform white box networking solutions. And our products today are deployed in some of the world's largest mega data centers. Also participating with us is our esteemed partner, software partner, IP Infusion, and Saji will share more about who IP Infusion is and the genesis of how they've come today and some of the great things they're doing in the industry. But IP Infusion is the de facto standard, if you will, for software-defined networking. IP Infusion was founded in 1999, and IP Infusion is the leader of embedded Linux network operating systems. So what I want to just briefly go over is the agenda. These are the topics we're going to be covering in the time we have together this morning. I'm not going to read all of those, obviously, but this is what we'd like to cover in the time we have. And leading off at the top, what we want to just sort of start discussing, and keep in mind today, we don't want to kind of kill you with PowerPoint by death. So we'd like to make today's session with you folks more of a conversational approach to kind of covering this topic and going over things with you individuals. So it's not going to be just a slide here and there. It's going to be conversational between the two subject matter experts, Saji and Daman. And what we'd like to start off with is sort of what is open networking and sort of defining that on our side here in the system perspective. So what I'd like to do is sort of pose that question to Daman and have him sort of be our leadoff hitter around that. But before Daman jumps into this, I apologize. Just a couple of quick housekeeping issues. All of you are muted. So we're taking care of any background noise. The slide deck is available to you folks as we speak, so you've got that on the webinar. And any questions that you have, if you'd be kind enough to use the chat box, I will be monitoring that chat box for any live questions. We'll try to answer them on the fly this morning. Any questions that require a deeper dive, we'll email you that answer. So that's kind of a housekeeping perspective. But Daman, getting back to the open networking, I'll let you run with this, please, sir.
Yeah, thank you, Nick. Open networking is all about more choices. Now, different aspect of open networking from server standpoint would be one definition. What we are going to talk about system perspective here is from the networking gear hardware standpoint. So what people see in conventional networking systems is that it is a vendor-locked system. It provides proprietary ASIC-based solutions, sometimes merchant silicon, but more about the proprietary ASIC-based solutions, proprietary OS, and proprietary architecture and management tools. So it's a deviation in open networking that deviates from what is a closed system to a more disaggregated hardware and the software platforms. And when I mean disaggregated hardware, it is about an open platform, provide open installer environment for you to bring into your own NOS or you can even develop your own nodes and open server tools that are available in today's. You could able to integrate into these open networking platforms. And Agima systems actually provides a number of platforms for you to choose from 1 gig to 100 gig, as well as the deep buffer switches. You now have a choice to build your own plus network using these TORs. From hardware standpoint, not only Agima that you could able to find out their offering, there are other vendors, and you can choose from. So this aggregation of hardware means it is providing you a choice, a more choice towards scalability, flexibility, and reduction of TCOs. So from a software standpoint, Saji, how do you see this is evolving? What is your analogy on all this stuff?
Hi, everyone. I basically see this as I would like to take an analogy of this fast food, which I saw someplace in another one of these presentations, basically. And there the viewer was basically telling how, you walk into McDonald's, you basically get this converged product offering and the disaggregated product offering. So essentially the kids' meal, right? In the kids' meal, you have a little bit of element of everything that they have to offer in the menu, plus a toy. Now, if the kid needs another a toy, you essentially end up buying another kid's meal. But it's good that they have it disaggregated because you can order each one of those things separately. So essentially, I view this, take this analogy and put it into the network. Now, you want to build a very high-scale IP fabric on top of which you basically want to offer services cheaper, faster, better. So essentially, this disaggregation basically allows you to do that with a choice of hardware and software, just like you do in the server side. You have a plethora of applications that you want to use, and the scale for running those depend from your use case, your particular use case that is pertinent to you. Similarly, here you basically get a choice of network operating systems that are decoupled from hardware. So you have this easy, simple building blocks on top of which you build a fabric on which you basically provide services cheaper, better, faster.
So, Saji, so you are referring several aspects of flexibilities and scalability, and of course, with that comes the reliability from IP Infusion as well. So, when you talk about server, you referred a couple of times server.
Yes.
This is a server-like experiences as opposed to another embedded system. You don't get that aspect, right? Am I correct on that?
Absolutely. When you look at the server side of the equation, right, today you basically have a choice of operating systems when it comes to Red Hat, Linux, or Windows. And in certain environments, a particular operating system works just well for that particular application. So here we are taking that experience further because our Open Compute network operating system basically works on top of Linux. Mm-hmm. So essentially you get used to the user interface, the tools that you already use to manage your server. And if you need one-of-a-kind application that fits in with your needs, you can easily extend it without that vendor lock-in or waiting for the vendor to actually provide it in their converged device.
So that means customer has a choice right now to choose between whether they like, if they are conversant enough on Linux, they can manage the box using the Linux command line.
Absolutely.
Bring in their own Linux tools-based, like a DHCP server and so on and so forth, if the hardware provides enough memories and so on. And also, they can get this server-like experience on one end. On the other end, they can just put one command, say, put me in a industry standard CLI, yep. And then they can go on the industry standard CLI.
That as well. So essentially, we provide a full-fledged management plane which gives you the standard CLI that you expect from leading vendors mm-hmm. of converged products. But it also allows you the flexibility to interchange it with the Linux-like look and feel, mm-hmm. and while allowing you to write specific applications for telemetry, for instance.
All right. So we talked about Agima's the product roadmap and depicting how a customer now have a choice to choose various different TOR with IP Infusion or Agima OS, giving them the flexibilities. Of course, it comes with the benefit of what open networking is offering. So open networks, the benefit is, it's more about open architecture as opposed to closed architecture. We talked about the vendor locked in, how it provides you closed architecture. Of course, there is an innovation there, but it is more about within one organization developing their own software and their own technology push, right? As opposed to in an open networking platform, you open up this entire industry to come in and join, and this also reduces the cost, right?
Yeah.
As well as it provides you, there are several benefits around reductions of TCOs in terms of CapEx and OpEx. So, Saji, do you have, from your standpoint, you see the same thing is that a lot of the customers are benefiting from deploying open networking platforms?
Absolutely, because I've been in the networking industry for the past 15, 16 years, and I've seen this transition where, we had a plethora of networking protocols, and for each networking protocol, to accelerate, you would build this custom ASICs. Now, if you start with the silicon itself, right? Forwarding silicon, now it has become commonplace commercial off-the-shelf silicon, which basically gives you cloth architecture right within a box. And once you have a versatile commercial off-the-shelf component, on top of which you can build this incremental building blocks, kind of like Lego blocks. So you can build out these scale-out architectures by putting it together without resorting to very complex topologies with different kinds of failure domains, which are not very deterministic. So essentially, I see this as you're making the network much more capable, but at the same time removing the complexity of the services, decoupling the services from the network fabric itself. So you have a high-speed transport fabric which comes in 1, 10, 40, 100 gig, and maybe possibly 400.
400 gig, yes, definitely.
With the deterministic behavior that you get with Ethernet. And it's pretty easy to understand, very simple to compose and create this large-scale IP fabric.
So when you are talking about this large-scale IP fabric, or the 100 gig or 400 gig fabrics, you are referring to cloth architecture, and cloth architecture means is that the fabric can be like 400 gig or collective fabric,
yes.
And you can have TORs connected to these collective fabrics, and you can extract the information from that fabric to manipulate and understand what's going on in your network. That architecture, it's nothing new, right? It
Absolutely.
came from the old age, I guess. What's your opinion on that?
Yes, absolutely. So Charles Closs essentially created this, he wanted to solve this issue of high-density voice. So for that, he needed a repeatable atomic unit that he could put together with very strict failure domains and very easy to compose. So kind of like Lego blocks, you have these few building blocks, and on top of which you build out this high-capacity scale-out architecture on top of which you could support multiple services. So that same thing is relevant today with data networking.
Yeah. And that brings us an interesting point about open networking platform is that the customer now can put their own choices of server tools to take advantage of this, right?
Absolutely.
As shown in this slide, that the customers now have a choice, and more choices comes from any OS they can. Not necessarily they have to choose a choice from us we are providing, but we are providing as a partner the best of the interest of our customer,
yes.
right?
Yes.
It's an integrated solution for the customer, but customer now have a choice to go and find their own OS or develop their own OS. At the same time, they can have a hybrid aspect of the network, and we'll talk about that one later as well. And they can now integrate OpenStack and other orchestration software as well as management tools. And that brings us to a interesting question, is that the open networking trend that we understand from what we have seen from the market deployment is that open networking trend it offers different flavors of or attributes as per C. One of the attributes is virtual network functions, and we have seen the VNF is implemented in a service provider network more from the server standpoint, and it's coming to the switches. Another aspect is programmatic management, and programmatic management provides various different APIs and integration to the tools like Chef and Puppet that customer can able to now automate their switches, and also, in fact, I mean, something like NetConf and Young modeling, and they can manipulate a lot of stuff. And of course, disaggregation of the network control. You can now take the network control using OpenFlow, rule, any kind of controller that you want. You could be able to manipulate the flows you want, and at the same time have the benefit of hybrid networking, right, where the traditional protocol suite exists. So from that standpoint, how, from the software standpoint, of course, how you are evolving, IP Infusion software is evolving to accommodate all these attributes that the customer wants.
Absolutely.
And what's your point, Shaji, on that?
Yeah, so essentially, just like in the voice, when the traditional voice networks basically came in on those TDM-based transports, from there, it migrated onto IP transport. So you saw that the transition phase basically covers quite a lot of time because not everybody moves at the same pace. So essentially, here too, we see that the existing networks would continue to stay in its state, the converged networks that we have today. But over time, you know, an SDM-based paradigm would evolve. So essentially, there is that transition phase. So your network operating system basically needs to be in both domains for the foreseeable future. So essentially, you know, you would basically learn routes from BGP, and you would also learn routes through the controller. So you need to delegate back and forth. It depends upon which function gets delegated by the embedded control plane or what gets taken care of by the controller. So both have to coexist.
Yeah, and also the server-like experiences we have discussed earlier that the customer can choose the flavor of Linux, right? For example, IP Infusion provides, and Agima OS as well provides. Agima OS provides Ubuntu Linux, Ubuntu 12.04, and IP Infusion provides Debian and CentOS. So customer now have a choice to put the full-blown Linux on their machine, at the same time take advantage of industry standard CLI and use the APIs. So the RESTful APIs and NetConf and Young is some of the APIs of SDN that they can able to do the programmatic control, right?
Absolutely.
In addition to OpenFlow. Right?
Yes, yes. So the way you want to look at it is like you know what your managed objects are, so you model it in a language that is neutral to the northbound interface. So essentially, you'll interface with multiple management systems. So for that, you need to have a flexible management plane which can easily switch back and forth between REST through CLI, through NetConf, or whatever is available with your current network.
Yeah, and then NetConf is being there as an RFC, and it's Young was the data modeling, and then now they togetherly work is like similar to this NMS system we used to use before, right?
Absolutely.
It's kind of replacing NMS system.
Yes,
right?
yes. And if you recollect, there used to be another standard called IMM, which is Information Model Management, which was very similar. It was a precursor to this, and there was the Backus-NOR format also from IBM. So essentially, if you look at it, each of this has evolved, and what it has come down to is basically in the application world, you're seeing this orchestration of multiple pieces coming together to form a service. The same thing is happening with the network orchestration piece, where you have these small decomposable units. They come together, they give you a service.
Interesting. So that brings us an important question that we actually talked about this hybrid aspect of the network, how arbitrations is occurring. And before I go to that point, just to let customer understand is that the VNF, which is the virtual network function, is like a load balancer, firewall, and for service provider perspective, they might have some of the teleco, the base station functions and so on and so forth that they put in the server as a virtualized network function. IP Infusion currently is providing that virtual network function on the server, right?
Yes, absolutely.
What was the OS name?
We have this virtual network operating system, which is essentially whatever you can run on a custom hardware, you could just as easily take that and run it on top of a standard garden variety server. So we built a forwarder which is accelerated using techniques like DPDK, ODP. So essentially you have the forwarding plane for MPLS as well as L2, L3. And on top of that, you have this standard switch control plane, which does MPLS, TP, L2, L3.
Okay, so that server-based BNF capabilities is sooner coming to the switches, right?
Some aspect of it, basically anything that needs to. I'm of the opinion that things that need to run closer to the hardware, it's better left there, and some things you want to scale out, and they're better served. Like for instance, you have things like in the wireless world, right? You basically are doing this RF planning. This RF planning basically is an involved exercise. It's a graph coloring problem. It's better done where you have more compute, not on a access point, basically. So some of those things could be uplifted. It would run in the cloud.
Could be implemented as a gateway. Right?
Absolutely.
So I talked with one of the service provider, and they wanted to do 100 gig switch from their cellular tower, all the flows coming in, and kind of do these millions of flows. And also do the load balancing functions within the switch, right? So they can drag and drop the applications on the switch and kind of manipulate the load balancing, kind of offloading from this the expensive servers. So the customer has the choice what they would like to do with the VNF,
how their network topology is, and based on that, for everybody, everything doesn't fit in, right? OpenFlow may not be the answer for every customer, but they may have aspects of OpenFlow which fits in very well, and they can do that particular function using OpenFlow cheaper, better, faster, right?
That brings us to this interesting question of arbitrations, right?
Yes.
Arbitrations is between a conventional protocol switch running in the switch, right? For example, OSPF, BGP, and what you have in this environment, which are very complex protocol, and you want them to run, and you don't want to play with BGPs on that unless you are an expert on that. But at the same time, you want OpenFlow to do certain the policies for your network. So how this arbitration is done in IP Infusion? How do you implement that in a switch?
So we do it in two levels, right?
Yeah.
One is basically, standard way, like in OpenFlow 1.3 specification states that. So essentially what we do is we basically trick the switch into believing that there are two data pipeline paths. So essentially one is, so you have a set of ports which are managed by OpenFlow, the other part which is managed by the embedded control, and then we have this arbitration mechanism whereby the controller decides which things to delegate to do on its own versus delegated to the embedded control plane. So that's how we basically do this implementation. The other one is, if you're familiar with Atrium, which is a project which came up recently, and route flow is another one, where we run our control plane as is on top of a controller, and between the controller and the Open Compute platform, you basically have something like an OSDPA based, if it's a Trident 2 architecture, and you have a driver that sits on the southbound side of the controller. So essentially what happens is, when a packet comes in, if it's a BGP packet, it basically gets to the processing unit that is sitting on top of the controller, the application, and it processes it, it converts that BGP into a flow, and vice versa.
Yeah.
So that's one way to build out a scale-out router without having to do a multi-slot chassis.
Yes. And another thing you could do is that a simplistic view of arbitration is that you could reserve a group of ports within the switch to do this conventional protocol, and reserve other group of switch ports to do your flow-based control.
Absolutely. You dedicate certain resources to, there are three methods, if you will. One is the ships in the night mode where, it's clearly segregated. They don't see each other. They are in their own domains. The other one is this interworking where, you stitch the two data pipelines together with a single control. There is one single control, which is the controller, but it's delegating functions. Some portions of the control plane is being delegated to the embedded plane. Yeah. And the third is this virtual chassis architecture where inside it's all OpenFlow. Then you, on top of that, you basically, on top of the controller, you have this standard control plane application which talks to the outside world. So multiple possibilities.
Yeah. So we talked about the class architecture and how people can now, they don't need to buy chassis, right? They can have the same density and management using a class architecture where the fabric switch and TORs are interconnected. And for customers, in this slide deck, I put the class architecture based on Agima switches as a backup slide, so you could go and refer to it. You have a choice now to do class architecture based on 10 gig connecting to 100 gig, or 40 gig connected to 100 gig, or 25 gig TORs connected to 100 gig.
Okay.
And and you can now able to monitor even the centralized fabric, right? And,
yes.
And I understand that on the Linux standpoint, you have Wireshark APIs, and you can connect from the server and able to manage the entire fabric and kind of manipulate the traffic that way.
Yes, absolutely. Like in the carrier Ethernet world, in the OEM solutions, right, we have the CFM, EFM. So there is the telemetry and instrumentation built right into Ethernet.
Yes.
So essentially, you can monitor the health of the fabric that way. And the failure domains are self-contained because it's all Ethernet, and it just works. It works right out of the box. So that is one of the attributes that you have with building this class fabric using Ethernet.
Yeah. So we referred to IP infusions or CNOS, and a few times we referred to it. Perhaps, Saji, it would be time now that you kind of give us a little brief on IP infusion, how hybrid aspect of it is being realized on this particular platform, and kind of describes how modular it is and what flexibilities it provides to the customers.
Yes. So as with any networking element, there are three major components that go into making a network element. Essentially, there is the data plane, which does all the forwarding functions. And then on top of that, you basically have the control plane and a management plane to manage all those applications that are running. So essentially, we are no different, but the way we do things is, our legacy is basically supplying control plane, all these components to OEM vendors. So over the years, we have made it very modular so that it can function across multiple chipsets, multiple iterations of network elements. So what we have done here is, at the bottom layer, you basically have the network silicon. On top of that, you have this modern operating system, which is Linux. But in theory, it could be any operating system. And we basically have a platform abstraction layer, which abstracts out all the functions, like the TCP/IP and those kinds of things. And on top of that, we basically have this base module called Network Services Module. Think of it like an interface manager. And we have a series of slots. Think of this like providing capabilities, protocol capabilities. So any new protocol comes in, you plug it in on top of this NFM infrastructure. And on top of that, we basically have a model-driven architecture, which gives you the flexibility to generate any kind of northbound interface. So essentially, you have netconf, REST, and so forth. And we tie all that together with middleware infrastructure, which allows you to have deterministic failure response, like a 4 nines reliability. So we have this middleware, which basically takes care of things like recovering from a control plane crash. So you want to keep that hardware up and running. And only change those routes which are relevant, which are stale routes, basically, when the control plane comes back up. Also helps you with the in-service software upgrades. If there is a patch available, just like you do on your server today, you don't need a complete reboot of your device. You can do in-service patches.
Modular reboot.
It's a modular reboot. It could just be a new application that came in. Like I want to add an extension to OSPF, like segment routing. So I could do that through an update. And it also gives you all these APIs. Over the years, we have catered to engineers. Our audience was typically engineers. So we developed a series of APIs for each one of these layers. And now it's written on top of a architecture like Linux. So essentially, we expose that and give you that API. So if you're up to it, you can actually extend our platform using Linux containers, kind of like what happens in an iPhone.
Yeah. So although, hold that thought, although we are going to move forward, but I want participants to, use the chat box to fire their questions. And as we move on and more in depth on those technological aspect of it from software as well as hardware perspective, we want to answer your question. Is there any question on the Breezy as of yet? But at the end of the presentation, we are going to also go for a few minutes of Q&A. Yeah.
So yeah, the plan is the last 10 minutes we'll unmute everybody, and you can certainly ask your questions then. But in the meantime, if you have any questions, post them in the chat box. I'll be looking at them, and we'll try to answer them on the fly.
All right. So now going back to this OSI-NOS modular and hybrid NOS, can you provide a little bit of history? I think you referred several times of how this was being done based on JEB OS.
Yes, yes.
And what was the background of the JEB OS? Where does this come from?
JEB actually is a short form for Zebra, and Zebra was basically, if you remember, Diman, there was this open source Zebra, which basically was written by our founder, Kunihiro Ishiguro-san. And based on that, there is the fork of that, which is Quagga, which is utilized by quite a lot of people. It's pretty popular. So our basic origins came out of Zebra, so that is why we have it as our traditional component model is basically a control plane offering, which is Zebra OS. And what you saw there as a control plane is exactly that. So it's highly modular, scalable, works across multiple platforms.
So customers now have a choice if their BGP, for example, crash or OSPF module crash, they can restart that without having to impact anything on the network, right?
Yes.
So that kind of modularities are there.
It's built into it.
Yeah.
And we also do some things in the hardware layer to make sure that there is an audit function so we don't blow the whole routes out. Yeah. Particularly when it comes to internet scale devices. So over the years, we've built modular chassis, we've built pizza boxes, and one-of-a-kind devices like application specific boxes, like appliances, for instance. So we have put some total of our experience here, and this has been in this operation. This software has been in continuous operation for the past 15, 16 years and well tested.
And this integrates to Agema systems in a very seamless way. For example, Agema boxes comes with its own core boot or U-boot. It kind of minimize the Linux boot up version, right?
Absolutely.
And then on the top of which we have ONIs with the diagnostics and everything.
Yep.
Even for customer buying a bare metal box, they could able to run the diagnostics on the box.
Absolutely.
And on the ONI, you put this OSI-NOS IP infusion software.
Yes.
So customers can have a choice. They can buy OSI-NOS from themselves and buy the bare metal from us, or integrated solutions with OSI-NOS Agema system boxes, right?
Exactly like in the server world, right?
Server world, yes. That gives them flexibilities, right?
Yes.
So we talked about OSI-NOS, the functional aspect of it. Let's go to a little bit of complex on the networking scenario. Now, people are hearing about overlay networking. Now, we understand overlay came from a desire to have LAN-based networking over IP networks, right?
Absolutely.
And how do you see this is evolving, and how IP Infusion's OSI-NOS is realizing this deployment?
Yes. So basically what you want is you want a classical networking, right? On your fabrics, on your data fabrics, you want to remove that complexity from the network, essentially. And you want to be putting more complexity into your application, into your network application. So kind of like what happened in the application world. So if you look at parallel compute fabrics like Hadoop, Spark, and all that, they don't rely on the underlying hardware, basically, completely, right? So they have their own mechanics, how to distribute a workload. So essentially, it's kind of the same concept here. So what you do is, like, you don't put a tunneling capability and all that right into the device itself. You create a series of overlays, and wherever it makes sense to accelerate, you put those points in the hardware. So you have this decomposable units, as I talk about, which is basically a simple Ethernet switch. On top of that, you have this virtualization domain where you can create any kind of service. And that service can be scaled out. Just like in the web world where you have this application server tier which you can scale depending upon the demand on the application, here you could have these composable units that run on a virtual compute platform. So that is the beauty. So essentially you get to provision services. You can turn on these new services cheaper, faster, better without having to tweak the silicon.
Yes, and going forward, what we are going to do is we are going to deep down in each of these technology. So for example, our next seminar in January is going to be on overlay network. We are going to deep down in the data center topologies, architecture, as well as kind of show live demonstration how VXLAN they can configure and have this multiple of data center connected over a BGP network, for example, in a seamless integration of as if the servers belong to
absolutely,
each other,
absolutely.
Right?
The intent here is to show what you get from your current converged network equipment provider, show you the same level of service that you come to expect from them, but on a much cheaper hardware, basically using custom off-the-shelf. Instead of using custom silicon, we are basically going to show this same architecture functioning with the basic building blocks, something like Trident 2 platform.
Yes, Trident, EGMA's Trident 2 platforms, right? AG7648, for example. Right. This brings us another question that we kind of touch over, right? We talked about hybrid flow switching and so on and so forth. And we talked about simplistic point of view, how people can realize hybrid networking using a group of ports to be reserved for conventional protocol and group of ports for open flow based flow control.
Absolutely.
And so that's, can you touch a little bit more about it before we go further on?
So to take a simple example, basically would be like a web service, right? A standard web service has this design pattern, which is model view controller. So essentially, you have a web server tier, you have an application server tier, and a database tier. Now you want to scale it. So let's say your service was very popular, it's very successful, and now I want to build out this newer rack at a much cheaper, 1/3 of the cost. So I want to bring the cost, the CapEx and OpEx down. So I'm going to use this new OpenFlow-based switching for Tor. So how do you stitch those two domains? Because you already have your network, which is operational, and there is this new domain. And you cannot rip apart and start all over again. For a greenfield, it may be a nice option. But in your case, you want to build it that way. So in order to tackle that use case, right, I just want to scale the web tier. So for that particular rack, what I could do is I could basically take that switch, the top of the rack switch, segment it in such a way that one domain is basically in OpenFlow. The other piece basically talks the standard protocols. So essentially what happens is there is a controller. The controller delegates that function to the ports that are managed by the embedded control plane. So you map a route into a flow. You get a BGP update. You basically take the routes learned from that and map it into flows. So your rack basically doesn't, it's totally oblivious to what is happening on the OpenFlow side of the world. It thinks as though it is talking to a peer device. So that is the construct. We'll get into that more detailed, through a demo. Later.
That would be a nice way to show
people how you can do
next seminar how these arbitrations are being done.
It's essentially using fine-grained control for things that you really need to have that fine-grained control. But the other things that work in the traditional way, it'll work in the traditional way.
Wonderful, wonderful. So we talked about programmatic aspect of it, SDN aspect of it, and NFV aspect of it. The world is moving towards a scenario where it would be an intelligent dynamic network solutions. To that aspect, customer may have a single service portal from which they can do template of service design. And how EGMA boxes fits in is that EGMA boxes, as shown in this presentation, provides, as I talked about, a thin layer of Linux environment, which is core boot or U-boot, and on the top of which you have network OS and you have OpenFlow agents or other APIs, management APIs, And then you could generally connect to the controller as well as to the OpenStack kinds of orchestration environment. So from SDN perspective, if customer imagines, if the southbound API is between the switch and the controller, and the northbound API between the controller and an environment like OpenStack, for example. So with OpenStack now, they can even with the plugins and APIs, they can able to, with the RESTful APIs coming, they can even able to do the templates and start pushing these service designs, right?
Yes.
And that's the world that we are moving in. I mean, it's just coming in like a click as a provisioning then as opposed to it takes days of provisioning for the people, right?
Absolutely. Some of those services, if you're familiar with, if you use AT&T as a provider, some of those services, you could add a channel today. Previously, it used to be that some 10, 15 years ago, you would call the operator and they would actually do the provisioning on the back end. Now you can go to a self-service portal and do that. And it's pretty much the same concept here.
Yeah, interestingly. I think we have finished up what we need to talk for today. The next seminar, we are going to discuss about this overlay networks and how you could able to take various different data centers or even the racks across IP networks and make it as if it's part of the same LAN. Right?
Absolutely.
And for example, if you have like I was experimenting with the VMware migrations or VM migrations using VXLAN tunnel, they can have a VTAP on the switches. Switch is going to provide a VTAP gateway. Agima switches provide the VTAP gateway, and they can have a VTAP gateway within the hypervisors of
network virtualization platform.
Yeah, any like VMware has the VTAP within their hypervisor. You need the vDistributed switch to do that. But then you can have that VTAP and this VTAP on the switch connect, and anything that sits on your server on the top of VMs. For example, you can have VLAN maps to the VNI on the VTAP gateway on the switch, and you can have one server, if the utilization goes higher, you can drag and drop.
Linearly scale.
Yeah, you can scale, and basically user is not going to realize if it is the server that you just moved your application and everything to New York server and back and forth to San Francisco server based on the utilization, user is not going to be able to see that. That's the benefit of tunneling like VXLAN tunneling provide and how Agima switches that. And we are going to discuss that in our next webinar. So having said that, and since we came to conclusion of this seminar, we are now going to open up the bridge for you to questions. And you can either use chat box or you can tell us if you want to discuss these things further. So go ahead and Nick, I'm turning the table to you, and go ahead and moderate.
So, and again, on behalf of all of us, we want to thank you for taking time out of your busy schedules to join us. Hopefully you found this to be time well spent. We've enjoyed socializing this for you guys. If anybody, I've unmuted everyone, so if anybody has any questions, comments, concerns, please join in. We'll address them. If there isn't any questions, then we'll give you some time back in your day, and we'll conclude. But we'll leave it open here. Any questions?
So this is Dimana again. Are you hearing us well? Just say, let's see if you are hearing us well or not, and if you have any questions. What about the question you may have?
Well, it sounds like whenever there's silence, that's a good sign, because hopefully we've answered all your questions that you had.
People are talking. I can see them talking, but we didn't hear them well. So why not you use the chat box and kind of fire on the questions. Thanks for that. Can you write on the chat box?
Okay. So I'm just seeing if they're all.
If people are speaking and for some reason we're not getting unmute.
Go ahead. I had already done that. So somebody, Harpreet, you had a question. If you want to readdress that.
Yeah, we are having audio problem. Looks like we are not hearing.
So now is it quite stable after keeping that?
All right. You can, if you, it seems like we are unable to hear you, but nonetheless, you can always send us an email. My email, you can note it down, dhiman.chaudhary@agimasystems.com. Fire on any question you may have. Send us whatever, also the feedback, and of course, when you get out of this webinar, it will ask you for feedback. Please feel free to provide feedback as well as your questions, whatever you have, and we really appreciate your joining today. And I apologize that we are unable to hear you for some reason. Maybe it's your end, perhaps, I'm not sure.
Okay, that's right. Did you want to, Sajid, give your email address?
Absolutely.
If there's any questions for you?
Yes. It is shaji.nathan, shaji.nathan @ipinfusion.com.
Okay. So that'll conclude today's session. We, again, really appreciate everybody joining, and have a great day. The holiday season is here. Please enjoy your holiday season, and we thank you. Take care. Bye now.
Right, that too from the radio when the entity is not even set up. Right. Yeah, I'll let the team know about it as well, just for an update. I'll be telling them when you get the as well. Because as you also know, you might be aware about it, you might be wanting to take public ideas as well.